In this video, you're going to get one of the most comprehensive overview of your immune system so you can begin to know how it goes haywire and how you can improve it. Now, the immune system is one of the most complex systems in your body, but even if you're not a doctor, you ought to know how your body works. And in this video, I'm going to show you what goes on under the hood of your immune system. And by you investing in this knowledge and getting even a basic understanding of this complex system, you'll be in a position of power to control your health and be laser focused on the key leverage points of your immune function to improve your health and quality of life. Here is a map of your immune system. It all starts with the bone marrow stem cells. Most of your white blood cells are produced in the bone marrow, and from the bone marrow, they can become different kinds of cells. So you have these cells right here, which is going to turn into megakaryocyte, which turn into megakaryoblast, then eventually turn into platelets. Now, platelets are the smallest part of your blood cells, and platelets can form what's called platelet aggregation. And when you get platelet aggregation, basically they clump together, and that purpose is to plug up damaged blood vessels. So you'll often see elevated platelet involved in atherosclerosis or other inflammatory responses. And you can see platelet in your regular complete blood count panel, your regular blood test. Now, the next thing here is that the bone marrow cells can turn into these myeloid progenitor. Myeloid means of the bone marrow. And from the myeloid progenitor, these cells can become mast cells, and mast cells are immune cells that can be involved in things like allergies, because mast cells can produce various types of chemicals like histamine. This is why you take antihistamine for allergies. And then that can be involved in parasites as well. Now, you also have these myeloblasts, which come from the myeloid progenitor, which can turn into these different types of white blood cells. So we have monocyte, neutrophil, eosinophil, and basophil. Now, the monocyte, these are large white blood cells that can turn into either dendritic cells or macrophages. Both of these cells are involved in what's called an antigen presentation, which means that these white blood cells will take a piece of the pathogen and then they'll present it to the cells on this side, which is going to help you to make antibody or long-term memory against that pathogen. We'll talk about that in a little bit. But these dendritic cells and macrophages come from the monocyte. Now, monocyte, you can also see that on your blood panel, on your CBC, complete blood count. You'll see monocyte expressed on your lab test result. Next, we have the neutrophil. Neutrophil are these white blood cells that can engulf tissue. The process is called phagocytosis. Phagocytosis means your white blood cells literally act like Pac-Man that engulf and swallow up a pathogen. Now, both the monocytes, these macrophages, and neutrophil, they perform phagocytosis, which means that they eat up pathogens. Macrophage, as the name implies, macro means big, phage means to eat. These are big eaters. They're really large cells that can swallow up a lot of different type of pathogen and cellular debris. The neutrophil, they're also eaters because they perform phagocytosis, but they're smaller than the macrophage, so sometimes we call them the small eaters. So the big eater, small eater, in any case, they all eat up pathogens, which is how your immune system protects you. Then you have the eosinophils. The eosinophils and basophils both contain a lot of granules and enzymes in them. So does a neutrophil, by the way. These white blood cells contain granules in them to help digest the pathogen. Typically, the eosinophils and basophils are involved in, again, allergies and parasites. The neutrophils and macrophages, they're involved in eating up bacteria. They can attack viruses or fungi and even cellular debris from your own tissue being injured. So why do these guys handle parasites and allergies? Because a lot of times allergens like dust and pollen and parasites like helminth they're too big to be engulfed through phagocytosis. So then these specific type of white blood cell basically will spill enzymes on the bad guy because she can't swallow them, so you might as well just digest them. So that's the purpose of these particular type of white blood cells. Then we have these complement proteins. Now, the complement proteins are not actually coming from the bone marrow necessarily. They're primarily produced by the liver. Most of the complement proteins are produced by the liver. And these complement proteins are basically protein that float around in your blood, and they're kind of like the landmines in your blood, so to speak. So if the pathogen kind of bump into the complement protein, it'll activate them, and that'll activate the immune response to either break down the pathogen by lysis or digesting them, or they can activate these antibody response through opsonization to attack the pathogens. Okay, so these complement proteins part of your immune system. Now, these macrophages, it's worthy to mention that there's tissue-resident macrophages, which means that they're macrophages that just float around in your blood. Most of these white blood cells, they're just floating around your blood, but some of them are present in your tissue. They live in certain tissue. It's called tissue-resident. They live there. So some of these macrophages live in the brain. The ones that live in the brain are called the glia cells or the microglial cells. These glial cells are involved in inflammation in the brain. Like if you get concussion or you have some type of brain inflammation, then these glial cells can get activated and that can cause a lot of damage. The liver cells, they're called the Kupffer cells. So you have these macrophages in the liver that perform immune function. Most people think of liver as detox organ, but liver actually handle a lot of these immune function as well. And then your lymph node in the red pulp, these are specific area in your lymph node that contain these macrophages. Again, their job is to eat up cellular debris, clear up, pathogens from your lymph nodes. And then your lungs, you have the alveolar macrophages, which help you to get rid of pathogens in the lung. In your skin, you have these Langerhans cells. These Langerhans cells in the skin help you to clear up any type of cellular inflammatory issues. In your kidney, you have macrophages. In your glomeruli and the little fine tubules to help you to clear out inflammation, infection. And in the intestine, you also have large amounts of these immune cells. This is why they say your immune system make up 80%, or 80% of your immune system resides in your gut, because your intestine has large surface area, and there are many tissue-resident macrophages in the intestine as well. Now, so this side of the immune system is also called the innate immunity. Innate immunity. Innate immunity means this is something you're born with, right? This is something that it's already there. These are white blood cells that are ready to go. Once they see some kind of pathogen, they're ready to chew them up, or they're ready to spill enzymes on them to protect you. Now, innate immune response typically happens very fast, right? It's kind of the landmines are already there. These white blood cells are always on patrol in your blood. Soon as some kind of pathogen comes in, they're going to be the first on scene to attack them. Okay. Now, on the other side, we have the lymphoid progenitor. Now, these immune cells are involved in what's called the adaptive immunity. Adaptive immunity means your immune system can actually identify a specific pathogen and make a memory cell against that pathogen. So in the future, when you come upon it again, you're ready to attack the pathogen. These lymphoid progenitors can turn into various different kinds of cells. One is called the natural killer cells. Natural killer cells are these immune cells that can kill pathogen, especially infected cells. So like a virally infected cell. If a cell is infected by a virus, your immune system knows that this cell is already infected. It's done for. Let's contain the damage. Let's kill our own cells that are infected by a virus so that cell cannot spread the virus. So natural killer cell does that. It kills infected virus, but it can also kill abnormal cells as well, like tumor cells and cancer cells. Natural killer cells do that. And then you have these T cells. These T cells, the other name for them is called the T helper cells. Okay. So T helper cells, why are they called T helper cells? Because they help your immune system to amplify the immune response, to turn it up, to communicate with different immune cells to coordinate this action of killing pathogens. Now, there's two main types. There's CD4 positive, CD8 positive. CD stands for cluster of differentiation, which means that there's specific types of protein that are expressed on the outside of these white blood cells that identifies them that way. The CD8 positive T helper cells are also called cytotoxic T cells. Cytotoxic means it's toxic to the cell. Toxic to what cell? Toxic to your own cells. What does that mean? Just like natural killer cells, these cytotoxic T cells kill your own cells that are infected either by intracellular bacteria or intracellular protozoa, parasites like malaria, or intracellular viruses. So the cytotoxic T cells kills virally or otherwise infected cells and also tumor cells as well. So they're very similar in that they kill the cells that are going bad. The CD4 positive T cells, they can differentiate and turn into any number of these different types of T helper cell. You see the Th1, Th2, Th9, Th17, Th22, T follicular helper cells, Treg cells, and the Th stands for T helper. That's what the Th cells means. And currently, there has been 7 to 9 that's been identified at a different type of T helper cells. There's going to be more that's going to be identified as research continues, but these are the main types that's identified. And there's a few that's really clinically relevant for people with either chronic infections or chronic allergies that doesn't clear up, chronic food sensitivity, people with autoimmune disease. This play a very important role in understanding this. So the T helper 1, these white blood cells or these T helper cells, they start as just these, they're called the naive T cells, okay? Naive T cells means they don't know what they want to be yet. It depends on what kind of infection that you have and whether you have allergies or you have parasites. And then these naive T cell will receive these signals. The signal could be cytokines. Cytokines are cellular messengers sent by the immune system in the form of interleukins or tumor necrosis factor, various different kind of chemical signal that tell this T helper cell, hey, we have a specific kind of pathogen. We want you to turn into this kind of soldier so you can attack that pathogen better. Okay, so it goes from a naive T cell and then turns into any number of these type of cells. The T helper 1 cells are the one that's going to talk to these innate immune system. It's going to talk to the macrophages. It's going to talk to the neutrophil. It's going to talk to the dendritic cells to go after the pathogen, to do phagocytosis and eat up the bad guy. Okay? Now the T helper 2 immune response, once these naive T cells turn into T helper 2, they're going to talk to primarily the eosinophils, the basophils, and the mast cells. And T helper 2 immune response is going to tell the immune system to, hey, we got some allergens, or we got something that's too big to phagocytize, so we need to activate these kind of immune cells to go digest the bad guy. So T helper 2 immune response is going to be involved in allergies or even parasites, mold, and so forth. Okay. Now, the next primary one we want to talk about is this T helper 17. Now, the T helper 17 is a type of T helper cells that can go after bacteria. They can go after fungi as well, like yeast. Okay, they kill pathogen through a different pathway, primarily by activating nitric oxide. Okay, nitric oxide is a gas that your body naturally produces. T helper 17 can get your body to make a whole bunch of it. And when you make a lot of nitric oxide, it's going to create this thing called oxidative burst. The oxidative burst is basically your body producing a bunch of hydrogen peroxide and these very caustic chemicals that's basically just going to bleach the pathogen to death. Okay, so T helper 17 is also used to kill pathogen, but T helper 17 can also be activated in people with autoimmune disease during autoimmune flare-up, and this has been shown to be the immune cell that's causing the tissue destruction in people with autoimmune disease. And by the way, we're talking about these T helper cells of different kinds. There's various nutritional supplements and compounds that can either support certain T helper cell or dampen other T helper cells. So that become useful tools for us to help to control our immune system in the way that we desire. The next one I want to talk about is this Treg cell. This is called T regulatory cell. So what that means is this particular T helper cell actually kind of puts out this calming signal on the immune system. It kind of reins your immune system back in and say, these are the immune cells that go kill pathogens. And this particular immune cell says, ceasefire, ceasefire. We're done killing the pathogen. The pathogens are gone. We don't have to keep killing anymore. So this is a dampening response. Again, very useful in people with autoimmune disease or some kind of inflammatory, chronic inflammatory response where we can help to calm the immune system down. And there's certain nutrition and other lifestyle things we can do to stimulate that. Now, all the way on this side here, part of the lymphoid progenitor, we have the B cells. Okay, now these B cells, again, are a specific type of white blood cell that are in the adaptive immune system. And B cells, they can turn out and pour out a bunch of plasma cells. And these plasma cells, what they do is they make antibodies. And antibodies, basically your immune system said, whoa, I met a bad guy, I met a virus, so I'm going to make antibody against that virus. So next time the virus comes, I already have circulating weapons ready to go to kill that virus. So then the virus doesn't stand a chance the next time you meet the same virus. This is a basis for your body building immunity after you get sick to something. This is also the basis for vaccines. If you get injected with the vaccine with a live attenuated virus or a dead viral particle, then your body will make antibody to that viral particle. So then hopefully the next time you meet that virus, you may have a better chance. Now, with these antibodies, you can have different type of antibody response. These are called immunoglobulins. Immunoglobulin or Ig, and there are many different subtypes. We have IgG, IgA, IgM, IgE, IgD. Now, the reason there's different types is because these different immunoglobulins may be released in different time of the infection. For example, IgM is released in the first phase of an infection. Okay, so it's going to be like the first few weeks of an infection. Your body's going to produce a lot of IgM as a first line immediate response. And then IgG will be antibody that's going to hang around your blood for months, maybe even years after the initial infection. IgA is a type of antibody that's going to be produced primarily in your mucosa. For example, in your mouth, in your nose, in your gut. So they're there to protect you in a route of entry where the pathogen can come in, like your mouth, your gut, or your sinuses, or your lungs. And then your IgE is going to be a type of antibody that's going to be involved in an immediate allergic response, right? So IgE is what's going to cause allergy, like hives and people with anaphylaxis to peanuts or something, then they feel the throat shut down. So that can be life-threatening. So typically medical treatment with antihistamine or EpiPen and so forth, they're treating IgE response. Okay, so the medical treatment typically does not treat IgG and IgA responses. The medical treatment for allergy is to treat IgE response. Now that makes a difference because food sensitivity, delayed food sensitivity response is typically an IgA and IgG response. So taking antihistamines like Benadryl will not help with that. So then we need to use other ways like nutrition or elimination diets, supplementation to help with these type of responses. IgD is usually involved in B cell antibody production. It can be found primarily in your eyes and nose, not so much in the gut. They're very few and far between of them. They're not the most expressed, and so they're not as important clinically. Okay, so mostly we're looking at these different antibodies, and you can remember them with the acronym GAMED. You got GAMED, G-A-M-E-D, GAMED. Okay, so that helps you to remember the different types, but the G-A-M-E, GAME, IgG, IgA, IgM, IgE is the most important clinically to us. All right, so now let's put this together. So here we have this innate immune response. Sometimes this is also called a T helper 1 innate response, right? Remember these cytokines? So these adaptive immune system, you can think of the innate immune system and adaptive as two main branches of the immune system. So this part right here is going to be your innate immune response. And then this part here will be considered your adaptive immune response, or sometimes they're called the T helper 2 immune response. Okay, so there's two main branches of your immune system that kind of they play like a teeter-totter balance. Sometimes what happens is when your innate immunity is really getting going, what happens is your adaptive immunity gets suppressed. And then when your adaptive immunity is getting really going, then the innate immunity gets suppressed. Now, the immune system is constantly doing this teeter-totter dance, and it's normal, right? Depends on whether you have, certain type of infection, whether you have, antibody response that's needed. It's always doing this dance. None of this is bad. This is all normal, and this is what your body does to protect you. It's only when these responses get out of balance, something's constantly stoking it, some kind of underlying trigger, or your immune system just get really out of balance and it can't swing itself back to normal. It just gets stuck in one pattern or the other. That's when it becomes a problem. And so we have this T helper 1 immune response on this side, or called the innate immune response, which are the immune cells that are first on scene to kill infection. We have the T helper 2 immune response, which produces antibody, which help you to be really like a sniper, right? So these will be the infantry guys that go in and just kind of wipe out the whole entire enemy population with big guns and bombs, while these adaptive immune system will be the sniper that will make it an antibody to a specific pathogen so that you can have memory, long-term memory against that pathogen. Now, you can see that they play together, even though they're two separate branches, but they're not separate. Everything's interconnected. So again, natural killer cells, they go after virus, tumors. Same thing with the cytotoxic T cell. They go after viruses and tumors. T helper 1 response, they can go after pretty much anything on this side. So this could be against bacteria, virus, principally. T helper 2 response going to be primarily parasites and allergens. Right? Anything that's too big to be phagocytized will be handled by the T helper 2 immune cells, and they're going to talk to these guys. There's communication happening between the innate and adaptive response, and then the T helper 1, they're going to talk to the neutrophils, macrophages, dendritic cells, and so forth. And then we have the T helper 17, which is going to go after your bacteria and fungi like Candida. And all of these can be involved in autoimmune responses. The Treg cell dampens or quiets the immune response. So it's kind of the conductor, if you will, or the ceasefire signal from the immune system. Okay? And then your B cells, they make antibodies, and the antibody can be against viruses. You can have it against bacteria. You can even have antibody against cell tissue. That's autoimmune disease. And then you can have antibody against even toxins. So you can react to things in your environment, right? You can have antibody against really, about anything, like even food as well, right? That's when you get food sensitivity response. So this is how the immune system is coordinated to help you. So in the following video, we're going to talk about how we can use this information to really help you to get better. So there's your comprehensive overview of the immune system. Hope you start to appreciate how wonderfully made our body is. Please let me know in the comments, what's the one thing that you learned? I cover so many things. I want to know what's the one thing that you learned out of this whole entire video. And if you got a lot of value out of this, please hit the like button. If you have not subscribed already, please subscribe to our channel so you can get notified of more videos just like this.